I'm really excited today to show you a full NFT course where we will generate AI images, we will develop Solidity smart contracts, and we will upload metadata to IPFS storage. My name is Roger, instructor at Crypto University, and I hope you will enjoy this video. Let's start about theory of NFTs. So NFTs are non-fungible tokens, and these are unique digital assets that are authenticated and recorded on the blockchain. Unlike cryptocurrencies like ERC20 tokens, NFTs cannot be exchanged on a one-to-one basis as they each have distinct quantities and characteristics. So if you imagine a piece of art and another piece of art, they are not exactly the same and they have a different value. But when you have US dollar, like a currency, you have $1 and another dollar, and both are exactly or have exactly the same value. NFTs enable ownership and verification for various digital items such as art, music, videos, real estate, and many, many more. In EVM chains, we use the ERC 721 standard. So we are implementing a standard such that we can represent NFTs within a smart contract. One misconception about NFTs is that the NFT or the digital asset itself is saved on the blockchain, and that's not the truth. Because let's imagine we have an image or a video. This has a quite big size, so a video maybe 500 megabytes, and storing that on the blockchain would just not work because it's too big. So what we are doing is we are just saving the footprint of such a digital asset on the blockchain. So we say user XYZ is the owner of the ID1 of this NFT. So we are doing one mapping between a user and which ID of NFT that belongs to him. And then we store a reference to the metadata, which contains the actual digital item, which is not stored on the blockchain. This metadata normally contains like name, description, image, so the digital item itself, image, video, and so on. Metadata is usually stored on a decentralized storage like IPFS, the Interplanetary File System. This ensures that it's efficient and it's resilient. So on such a decentralized storage, if one node goes away, it's not deleted within this cloud storage. So it will always be there within this cloud storage. If we would save it on our server, we could just delete or not pay the server anymore, and the digital asset or the metadata itself would not be accessible from the internet anymore. So that's why we would like to save it on a decentralized storage. Let's go to the ERC 721 interface. I open here the ERC 721 standard, and we can see the interface looks as that. We have some functions similar to the ERC20 token. We have a balance of with an address of an owner. So how many items does the one owner have? We have owner of a token ID. So we can give a token ID and we can see who is the owner of this token. We can do transfer from, safe transfer from, and transfer from, similar to ERC20 tokens if we would like to transfer the item to another one. Safe transfer and transfer, there is a little difference. So if a client is a contract and holds an NFT, he needs to implement a specific interface, and that's this ERC 721 token receiver interface. And when we use safe transfer from, we can ensure that the receiver can handle the NFT. So if we use transfer from, you can see it here, the caller is responsible to confirm that 2 is capable of receiving NFTs, or else they may be permanently lost. So if it's a contract and it doesn't implement the ERC 721 token receiver interface and cannot handle the NFT, it will just be stored on this contract and it cannot be accessed anymore. So it's lost. So the safe transfer from prevented from that. We have an approve function, so to approve a spender for the NFT such that it can be transferred. We have approval for all, so that's often used for NFT marketplaces. We approve the marketplace for all our NFTs such that all our NFTs can just be listed on the marketplace and get approved. That's clear. So get for who it's approved, the token ID. and is approved for all. We can just see if is approved for all for an owner. And then we have the ERC-165 interface. This just shows, or this just implements this supports interface function such that a client can see that we are actually implementing the ERC-721 interface. So this is kind of flagging or showing that we support ERC-721. So let's come back to the slides. Let's talk about IPFS storage. IPFS storage, as I said, is a distributed system where files are addressed and identified by their content rather their location. I will say after what I mean with that. And it's using cryptographic hashes for that. So when we look at this little illustration, we can see that in the IPFS world, we have different nodes which use a peer-to-peer protocol to exchange files and content within system. So let's say we have a node and we store one file, let's say an image on node 1, and then it will automatically connect to other peers within the system and it will replicate this file in different nodes. So let's say node 1 goes offline and then the file is still stored on node 2 and it can still be accessed from outside. We have an HTTP gateway. So within this cloud or within this IPFS storage, we are using the IPFS protocol, but with a HTTP gateway, we can access data from the IPFS storage from outside, from the HTTP world. So let's say from a browser. So how is the location of the data defined? We are hashing the data. We use a hash, a cryptographic hash function on the data, and we get a location. So the hash itself is the location within IPFS. This ensures that nobody can change the data. So the risk is, let's say we upload one image on node 1, it gets exchanged with node 2, and node 2 is a malicious node and changes the data. Let's say it changed the image. So if we request the image from node 2, it will be another one, right? So we want to ensure that this data always stays the same. So that means the location is defined by the hash of the data. And the hash, when the data is a little bit changed, the hash gets completely different. So let's say you have an image and node 2 changed just one pixel of this image. The hash of the data of this new image will be another location. So that means it will not be the same file anymore. And with this hash of data, we can ensure the integrity of the data and that it's immutable. So when we upload it on IPFS, it will be always the same. Doesn't matter on which node that the data is stored. After the theory part, let's now get our hands dirty and let's develop our own smart contract for NFTs. And let's upload the metadata to IPFS, connect that together, and then let's see if we can list it on OpenSea. We will start with the smart contract part. So I have opened Remix Solidity. You should know about that already. So what we are doing is we create a new smart contract, which will be our NFT contract. So let's go to new file and let's call it catsarmy.sol. So we add the SPDX license identifier first, then we add Pragma Solidity and the Solidity version. If you don't know what is this about, you can see my other video where I go through all the basic steps of Solidity programming. And we start with a contract which is called catsarmy. And that's just a simple contract. So what we would like to do now is we would like to use OpenZeppelin ERC-721. So let's search that ERC-721 OpenZeppelin, and they are providing us with a smart contract which already implements the interface of ERC-721. So we can see we can just import that and we can extend our contract such that all the functions of an ERC-721 token is included within our token or within our contract. So they are importing this ERC-721.sol. What we would like to do is we import an extension of that, so we add some more functionality than the standard ERC-721. We want the ERC-721 enumerable extension, which has a counter of how many tokens are out there. So it adds a total supply to our contract. So how many tokens are there? This will help us for after listed on a marketplace like Opensea to have such a total supply. So what we do now is we just extend it. So we say cat's army is ERC 721 enumerable, and we get an error because ERC 721 enumerable or ERC 721 has a constructor which we need to call. So we can add a constructor and we call the constructor of the ERC 721 token with a token name that's same as ERC20 token. So we say cat's army and we want a symbol, we call it CS. That's our constructor, and now everything is fine. Our contract compiles successfully and we can deploy the contract to the testnet. We can see when we deployed it, we have many view and write functions. So these are all these functions that we have seen before in the ERC 721 specification. And we have some more, for example, the name, the symbol, which use some metadata for our ERC 721 token. And we also have total supply, as I said. This comes from the ERC 721 enumerable extension. And we have more other functions, for example, the token URI, which gives us the location of the metadata of a token. So let's say the token URI of the token ID1, and it gives us the location of the metadata for ID1. Token owner by index, this comes from the enumerable. Token by index, this comes from the enumerable as well. The supports interface function, we know that. And these are all like standard functions for the ERC 721 token. So let's talk about the token URI. What I would like to do now is I would like to just mint a token for the beginning. So I call the internal mint function from our extension for the message sender, and I mint an ID1. So this is the ID. The first is to who I would like to mint it, and the second is which ID I would like to mint. So I would like to just mint ID1. And if we save that, we redeploy our contract. Now we can see the token URI for token ID1. And we see that's just an empty string because we didn't specify the base URL of our collection yet. That's what we do now. So we create a function which is called base URI, and this is an internal function, and it's overriding a function from the ERC 721 enumerable extension. It's a view and it returns a string. So this returns the base URI. And right now it returns an empty string. And what we would like is we would like to return our URI to our IPFS storage, where we will store our metadata afterwards. So we return the base URI, and this variable is not yet defined. So let's define that in our constructor. We say the base URI is equal to string memory base URI, let's call it like that, and we assign it here. And of course we need to create a storage variable string private base URI. So what we have is we have a global variable or a storage variable base URI. When we set up the contract or we deploy the contract, we need to provide a base URI. We set the base URI, and then this internal function now takes this base URI that we have set in the beginning. Let's see if that works. So I delete our contract. I want to deploy it. So let's compile it first. Now we see when we want to deploy it, we need to provide a string. So we need to provide this parameter. I will just enter something. And when we go to see token ID 1, what is our token URI? We see it's SDF blah 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 and 1. So he just adds the token ID at the end. So the idea now is that we have a fixed URI for our collection, and then we have /1, /2, and so on for the different NFTs. So for the first image, for the second image, and so on. And with this token URI function, we can access the metadata, the image itself, and so on from the collection. So what is the next step? The next step is we would like to add a mint function. We don't want to have it here in the constructor. We would like to have a function which mints our NFTs. So I create a new function. It's called mint token, or just mint. Let's call it mint. Address to. So we can say to who we would like to mint it. We make it public and it returns a uint256. So it returns the created item ID. What we can do now is we can create a counter. So I'm creating a uint256 counter, which is used to count up the IDs which we will assign to the new minted NFT. So uint256 new item ID is the counter plus 1. So we take our counter and we add 1 to that. So in the beginning it's 0 and we add 1 to that. So the new item ID starts with 1. And then we require that the new item ID is smaller or equal to the max amount. So the max amount we need to specify all already minted. So we don't want to mint more tokens than we actually have. So let's say we have 5 images. We don't want to mint more of these images because otherwise there will not be metadata for these images. So we want to have a maximum amount of NFTs that can be minted. So we define it here, uint256. Let's make that public, that we can see it, the maximum amount, and let's say that's 5. So we don't want more than 5 NFTs minted. And now we can just mint the NFT to this user, and which ID is the new item ID that we would like to mint now. And in the end, we set the counter to the new item ID because we want to increase our counter such that it's always increasing and that the next NFT will have a higher ID, so higher by 1, and we just return our new item ID. And that's it. So we have a public function where just some people can mint our NFTs. So this is not authenticated anything. The people don't need to pay it here. So what we could do is now we could say people need to send some ether to this function in order to mint an NFT. We can also set it just the owner. We can do an authentication that only the owner can mint NFTs. But for simplicity here, we allow everyone to just mint tokens. So let's see how that works. I will deploy it again. I will add some URI in the beginning, and we have now our mint function where we can say an address to. So we add an address and we can mint it for this address. Okay, we have a problem here because we have minted already 1 in the beginning. Of course, we need to delete that. So, and let's redeploy it because we don't want to mint on the constructor any item. And now we can mint a token. So let's mint it. It worked. Now we can go to see balance of this owner. He has 1 token. We can go to see owner of token ID 1. It's this owner that we have specified to who we minted. And so on. So we can continue minting for him. Second, third, fourth, and fifth. So we should have a total supply of 5 now, a balance of him of 5. So he owns all the tokens. And when we mint again, it reverts because all already minted. So what happens is the new token item ID is now 6 and the maximum amount is 5. so it will not work anymore. So we cannot mint more of these NFTs anymore. That was the part for the smart contract. Now we will go to generate our images, so to generate our digital assets, and then we will see how we add that to an IPFS storage, and in the end we will connect these both concepts together to create our full NFT contract. Let's create now our 5 Cats Army digital images. We will use AI for that, the Stable Diffusion model. How I downloaded and set up my environment here you can see in the description below. I will not go more into detail of that, but what we have here is now we can use a prompt, so we can use text to image. We are using some words which will generate us some images. So let's say we want cats and army, really simple. If you are more creative than me, of course, you can choose other keywords here. What I will do is I will set batch size to 5. So I would like to have a batch with 5 different images, and I just press generate and it will generate me some NFTs for that. Let's wait. We can see here the progress bar. My graphic card is now creating these images, and we see here are already some images that are generated. So let's see them. Okay, that looks fine. That looks like an army, right? And is even more. That's nice. So I'm happy with these 5 images, and now I can use them to upload them to IPFS. Next to the image itself, we need some metadata. So we need some name, description, and so on for our NFT. And what I normally do is I go to Opensea, metadata, which has a specification on how metadata should be ordered. So we can see here, Opensea shows how the metadata needs to be for how it will show on the web UI of them. So what we see here, the metadata should have a name, a description, and then an image, and that will be a link to the actual image that we have generated before. So what we need to do is we need to generate this metadata for each of our Cats Army image. For that, I have our images here ready that we have generated before. I will generate a new folder and I call it images. I add all of them into here and I rename each of these image to 1, 2, 3, and 4, and 5, such that they are the same as the token IDs on the smart contract, so that we can reference them in the end. And what I would like to do is now I make a new folder called meta, where we have stored our metadata. So what you can do now is you can open up your favorite editor to generate these metadata. So I'm using Atom. I'm opening the folder of where I was. So I was here in Stable Diffusion Web UI. I'm going to outputs, text to images, and here we have this meta folder. I just opened that up. And now I'm creating a new file called one.json, which is a JSON file for our metadata. So we make a name. This is our first Cat Army token. We have a description. So cats are cool. And we have an image where we will add the image URL of our image when we have uploaded it to IPFS. So we don't really know that yet. So let's just do that. And we will create some new files. So for the second one, I will fast forward here. So what I've done, I have just copy and pasted it for the second, for the third, fourth, and fifth, and I just changed here the name for these tokens. So we are all set now for using IPFS. For that, we are downloading the IPFS client. We can download it from the IPFS page. I'm using Windows, so you need to just choose the one that fits for you. I need the Windows version, so I can find it here. I need the exe. I'm downloading the exe, and I will just install the IPFS client on my local machine. So IPFS is successfully installed. It takes some time. Maybe you get an error in the beginning before it connects to its peers. Now it's connected to the peers, and you can already see it's kind of already have incoming and outgoing traffic. So my client or my node is already storing some data from other nodes. I didn't upload anything. But if I go to upload, I can go to files. Let me just delete these two so it doesn't confuse. So what we can do now is we can upload our images first. So let's import the files. I'm going here to import file. I'm copying the path to our images, and I just upload all these images. And you can see it was successfully uploaded. Now it will transfer that to other peers such that it gets duplicated. And we get this CID that we have talked before here down. So for the first image, we see this QM. This is the unique ID for this image. So what we can do is we can copy this CID. We come back to our JSON files, and we just add these CIDs to image. And in front, we say that's IPFS. And like that. So that's the IPFS link to this image now. And I will just do that for all the other images now. So we are done. We have just copied all the links to the right JSON file. And now we can also upload the JSON files to IPFS. And how we do that, I come back to, so I'm here in files, right? And I import now a folder because I want to upload the metadata folder itself, such that I have a unique CID for the folder itself, which I can then use in the smart contract as the base URI. So I'm uploading a folder. We are going here and I just choose meta, and I'm uploading the metadata folder. If we see that here, when we go inside the folder, we have all our JSON files with a different hash. But the folder itself has a hash as well. We can copy the link, which will give us the gateway link to the IPFS file. So I copy that and I open a new tab and I just search for that, and we can see that this is now stored on IPFS. So I can go to ID1 and we see our JSON file for ID1, and we have the image itself. So when I go again to the IPFS gateway /IPFS/ the CID, we will get our image, which is also stored on IPFS. And as you can see now, when I go to IPFS, and then I copy the folder CID, I can add that here. And now I can say /1 to get the first one directly, or /2 to get the second one, and so on. So these are the URIs which we have defined within our contract. So when we see here, we have the IPFS link to the first one. And for the second one, I think I haven't minted it yet. Here, the second one. Yeah, I get an error because it's an invalid token because I haven't minted it yet. So let's mint it. And now the second one is here. So we see the new IPFS URI with /2. Let's deploy this contract to a test network and let's see if we can really show the data on a marketplace like Opensea. For that, I will choose here injected provider, and you can see it automatically connects to my Metamask, which is connected to the early test network. And with that, I can deploy our smart contract using the IPFS URI to the metadata folder. So copy CID. And here I say IPFS. And I copy the CID and I add a slash in the end. And I press just deploy. MetaMask pops up and I confirm the transaction. And now it will be deployed on the Gurley test network. We see that it's done and it's successfully deployed on Gurley. When we go to the test to Etherscan, we can see the transaction was mined and the contract was deployed at this address 15 seconds ago. What you can see as well is we already have a token tracker because Etherscan already realizes that this is an ERC721 token, and we have here the name and the symbol. We can go to the token tracker and we see total supply, holders, and so on. Currently we don't have any holders because we didn't mint any NFT yet. So what we can do is we can start to mint some NFTs. So let's choose this account. I will mint one NFT. Confirm that, and the transaction went to Gurley network. You can see it's still pending and now it's indexing, so now it's successful. And we can see Cat's Army token with ID 1 was minted, so it was generated from the 0 address to this address that belongs to me. And when we go to the token tracker, we can see now we have a 1 CS total transfers, so 1 mint that was done. Let's see if we can see some detail of this NFT. But what we see is that our contract is not verified yet. So when we go to the contract address, we can see when you press to contract that here it's just the bytecode. So we would like to have the contract here without only having the bytecode. So how we can easily do that? We can say verify and publish. We choose Solidity single file and then the compiler version, which was 8.18, I guess. Yeah, that's true. And our license, this is none. So we have license identifier unlicensed. So we continue here and now we enter the Solidity contract code. How we do that is we come back to Remix, we press a right click on our contract and we say flatten. And now the contract gets flattened. That means all the dependencies that we have goes into one file. So we can copy all the code and we just print in here and we say verify and publish, and hopefully it verifies successfully our contract. We see that successfully generated bytecode, blah, blah, blah. So we have now a verified contract. When we come here to the contract, we see this check mark here and we have our source code, which was successfully fully verified. If we come back to this view where we had the NFT, we see that now it says the contract is verified. What we can do now is we can search this contract on a marketplace like Opensea. We just copy the address and we open testnets.opensea.io. So this connects all the testnets together and shows our NFT collection. So let's paste it in here and we see we have one collection called Cat's Army, which has one item. We have only minted one item yet. And tada, we have our NFT. So we can see the image, we can see the name of our image, which is stored on IPFS. This is our first Cat Army token. And when we go here, we see some description. Cats are cool. All the data that we have uploaded to IPFS. So what we can do now is we can connect here with our account as we were the deployer. Our address can connect here and style up all this page. We can add some profile photo, some banner image. We can add some description here on OpenSea, and we can also see some details that it was minted. We can list this item when I connect my wallet. Let's just do that quickly. I connect this wallet to OpenSea. I need to sign something for login, and we see we can list for sale because we are the owner. We own this Cat's NFT. We can list it. and other people can start to buy it. Let's just list it for 0.01 Ether. We confirm that, and we can just wait until we have approved the collection for Opensea. One more signature request. Let's sign that. And your item has been listed. So now it's 0.01 Ether for someone that can buy this NFT. As you have seen, when we go to Cat's Army, we only have one NFT. What we can do now is we can mint more NFTs. So let's mint a second one. Confirm that. And let's check that out. So transaction is pending, indexing. It takes a while, sometimes on testnets. Let's see if it's already on Opensea. We refresh here. Opensea already realized that there is a new item. He didn't fetch the metadata yet. This takes always some minutes. We can also refresh here and say refresh metadata. Sometimes it's a little bit more fast, like now. So we can see now it's already shown all our data. So our image, our metadata, and so on. So we have now 2 NFTs. I will just mint all the NFTs and show you after what we got for a result. Okay, I have mined all the NFTs now. Let's come back to our collection, refresh here. We have already 5 NFTs and some are already indexed with the metadata. Let's go to refresh and let's see how it looks like. Yeah, this always takes a little time. So you can see now it's coming. And now we have all our Cat's NFTs on Opensea. We can list them and transfer them. One more little thing that I would like to show you is that we can also access the NFT through Metamask. So if we own the NFT, we can show them here. We see it's not shown yet, but we can import NFTs and we can add the address and a token ID. So let's say 1. And we can add that to Metamask and it will automatically show all the metadata and the image itself on Metamask. And like that, we can just import all the NFTs that we own. So I have here one little problem. So let's say import NFT again. Let's use the second one. And we also have the second one now listed here. This was the full course about NFT. You have learned how to create an NFT contract, how to upload metadata to IPFS storage, and how to generate images by AI. And connecting all these concepts, we can easily generate collections of NFT. So thank you for listening. And if you would like to see more about blockchain development, Solidity development, you can see my introduction course that is 2 hours explaining all the concepts for Solidity, or you can check out some ERC20 tutorials where we generate ERC20 tokens and deploy them and provide liquidity on Uniswap v3. So thank you for listening and see you later.